Well, hi there and welcome at another screencast on TypeScript design patterns. And in this screencast, we will be discussing the observer pattern. When we look at the definition, it states that it defines a one-to-many dependency between objects so that when one object changes state, all its dependents are notified and updated automatically. So what does this mean? One object can observe another object and get notified of changes. When we look at the UML class diagram over here, we notice that we have a subject where we can attach an observer and detach an observer, and when something changes, it can call notify. So this is the abstractor interface, and this is a concrete subject which implements it, and we have observers which should have an update method and a concrete observers that implements this interface or abstract class. And in that way, when you create a concrete object and a concrete observer can attach itself to the concrete subject, and when the subject changes, it will call notify, which will do a for each through all the observers and call the update method. So this UML class diagram is from the book Gang of Four, where they describe the pattern. If we look at modern languages, however, most of the times this observer pattern is implemented through events. So in my example, which we'll go to a little bit later, I used events as well. And if we look at the .NET framework, for example, you see that used as well with the iNotify property change interface. This is used a lot in, for example, model view controller architectural patterns, where a model will observe, a view will observe the model in a way that as soon as the model changes, the view will also change. So AngularJS uses that. So let's have a look at the example I created with TypeScript. Even though TypeScript does not have a notion of events, we can still create events or use events, but we do have to do a little bit of groundwork to be able to do that. So the first thing I did, I created an interface called iEvent, which has an add and a remove. And when we look, when we think back of the UML class diagram, it stands actually for add observer and remove and detach observer. Okay, so with this interface, I also created a event class. And the event class, of course, implements the interface by having the add and the remove, but it also has a method called raise. To the client class, which uses this event, however, the raise method will not be visible because we will be exposing this event through its interface. So observers can only add or remove an event handler, and they cannot themselves call the raise method on that. So we have the event and the iEvent. Then we have the property changed. Property change is just like in the .NET framework, where we have the property changed event args. We have a property name, we have a before value, and we have an after value. Okay. This is immutable, so in the constructor we set the property name, the before and the after, and we have these properties, property name, before and after, which will just return. There's just a getter and no setter. So that's property changed event args. Then let's head over to the iNotify property changed. And the iNotify property changed will only defines a property changed event, which is, like I mentioned before, exposed as an iEvent. So every object that implements iNotify property changed will have an iEvent, which allows observers of that object to add an event handler or remove an event handler. Okay? So here we have an observable object which implements iNotify property changed. As mentioned, it will have a property changed event, and it indeed is exposed as an iEvent property changed event args. Okay. The other thing that it has a protected onProperty changed, which internally calls the property changed raise. And because internally this object is an event, it can internally call the raise method, and the raise method will loop through all event handlers that are registered and call them. So we have the observable object, and then we have an employee which extends observable object. Because the observable object itself does not have any properties that can be changed, we create an employee as an example in this case, which extends observable object, so it has the event and the onProperty change method, but it will need to do some work in the setters to actually trigger this event. So let's have a look at the employee. It has just two properties, a name and a role, and these are private variables. So inside the constructor we set the private variables. It is important, of course, that we do not use public fields, because we need to do something when these fields change. And the only way we can interact or interfere with this setters is by actually defining a specific getter and setter on these private fields. So let's have a look at the name. The name, when we call a get name, we just return the private field underscore name. In the set, however, we do two things. The first thing we'll do is we verify if the name is not already the same as the value. Okay? If it is not the same, we are having a change. So what we first do is we create a new event args, new property change event args. We state that we change the property called name, like over here, and then we set this underscore name, which is the old value, and the value that is passed to the method. So our property change event args now contains the name of the property being changed, the old value, and the value that we will be going to set. We then first set the internal field underscore name to the new value, and when this is done, we call this on property changed. Same goes for the role property. When we return, I see a typo. When we return the role, we just call return this dot underscore role. Okay, that's the private field that we return. When we call set, in the set we verify if the internal field is not already the same value as we're trying to set. If it's not, we create new event args. We state that we change the property name, property role, and with an old value and the new value. We then set the value of the internal field, and then we call this on property changed. And I also have, just as an example, a is dirty property, which returns a boolean to tell whether it's dirty or not. Because of this, I did something a little bit extra. I did override the on property changed, so I override it by setting this is dirty is true. Okay, because when I now change either the name or the role, we know that this object is dirty, it has changes. And this is something you see a lot when you want to do, for example, updates on items. If I have hundreds of items, I only want to send an update on the items which are dirty. So what I did over here is override the on property change. And as soon as this either property changes, I will set is dirty to true. And the other thing I do is I call super on property change with the past event args. The super on property change calls the base class over here. The base class calls the property change raise. So it calls the raise on the event, and the raise on the event, when we look over here, will iterate through all the event handlers which are registered, which are added over here to this event. So when we then look at the final part of our code, we have an event listener, and inside the event I create a new employee, and I create an employee with a name called Wesley, and his role is developer. And then I add an observer, and the observer in this case is just a simple function. I could also create a specific class which has a method that I would like to add as an observer. But in this case, I use just a simple function. And what this function does, when the employee changes one of its properties or has a change on one of its properties, it will call this function or any other function that is registered, and then it will pass the sender, that's the object that is actually changed, and the property changed event args. With that, I can log to the output the property with the property name changed from the before value to the after value. So I first created an employee, and then I added the observer, in this case a function, to the employee, and then I changed the name. I set the employee name to Norbert. Then I changed the role and I set it to lead developer. Then I changed the name again to Jos and the role again to junior developer. The result of all this is that because as soon as I change a property, the onProperty change will be called, which triggers the event, that for every change on every property, this function will be executed. So I expect to, in my output, see that the property name changed from Wesley to Norbert. Then the property role changed from developer to lead developer. And then the property name changed from Norbert to Jos. And then finally the property role changed from lead developer to junior developer. So let's see if it all works. Save it out, because I made a change. Head over to the page, refresh the page. Let's have a look. The property name changed from Wesley to Norbert indeed. The property role changed from developer to lead developer, Norbert to Jos, lead developer to junior developer. And in this way, I can create a system where one object observes another object, and as soon as some of its state changes, the object will be notified of the fact that there has been a state change. And again, this is used extensively in MVC frameworks, either client side or server side, to indeed get notify the view of the fact that the model has changed. And because of that, because the model has changed, a lot of times you want to update the view. And that is how you use the observer pattern.